Hi, my name is Greg Arcand, and today I'm going to be presenting a machine learning approach to an identity security application. It's to detect high-risk login behavior in identity access. The goal is to identify account takeover and abnormal access patterns using both supervised and unsupervised methods, while also understanding what factors are driving risk. Today, identity has become the primary security perimeter. That's because most modern breaches typically involve stolen or compromised credentials rather than traditional network attacks. Some of the big challenges are account takeover, abnormal access behavior, and insider threats. Those are three key risk patterns. And they're difficult to detect manually, and that is especially significant at scale. Because of this, organizations need to adopt automated data-driven approaches to analyzing authentication logs and identifying risky behavior. The core problem is detecting anomalous or high-risk login behavior using authentication data. And there are a couple questions we want to answer, which are first, can we distinguish between normal and malicious logins? Second, which features are actually indicating the risk? And we also want to know what other patterns we haven't found yet, if we can find some using unsupervised learning. Now, as for machine learning tasks, we're going to break this problem down into two separate machine learning tasks. The first is binary classification, which we label each login as normal or high risk. The other one will be anomaly detection, where we identify a behavior that deviates from a user's normal pattern. Using both approaches together improves detection coverage, especially for unknown threats. The hypothesis is that the login metadata is going to contain some pretty strong signals for detecting risk. This includes information like location, device type, network characteristics, and login timing. We're going to use models like, or I should say, I'm going to be using models such as gradient boosting to learn patterns in the data and predict whether a login is considered to be high risk. I'm also going to use feature importance to understand which factors contribute most, which is especially important for interpretability. And as for the learning types and models, I'm going to be using both supervised and unsupervised learning. Supervised models learn from labeled data, such as, in this example, known account takeover events to make predictions. Unsupervised models can be used to detect novel or previously unseen anomalies. I'm going to be comparing a few different models, primarily logistic regression, random forest, and gradient boosting. As for the data and features, the dataset consists of authentication logs with detailed information about each login event. That includes user identity, timestamp, IP-based location, device and browser information, and other network information. It also includes labels such as whether the login was successful, whether the IP is known to be malicious, and whether the login represents an account takeover. The main outputs I'm going to be working with are going to be a predicted label indicating whether the login is high risk, a probability score representing the risk level, and of course the feature importance rankings that will explain the model's decisions. As for the expected results, I would predict that gradient boosting will probably outperform baseline models. And some important features are going to be, I'll be looking at location anomalies, device changes, and behavioral deviations. And of course, unsupervised models are expected to identify anomalies that are not captured in the labeled data, which is important for detecting new attack patterns. These two approaches should provide strong and flexible detection capabilities. Success is going to be measured using standard evaluation methods. So the main metrics I'm going to use are going to be recall, precision, and of course feature importance is going to be used as well. The higher the recall, the better, so that way it's a little bit more reliable. And the higher the precision is, the better it is at helping to reduce false positives. Let's see. Overall, this project applies machine learning to a real and critical security problem in identity and access management. Instead of relying mainly on static rules and manual processes for review, this approach is going to use behavioral data from authentication logs to automatically detect potentially risky or abnormal access patterns. A key aspect of this work is not only focused on prediction accuracy, but also on interpretability. And in security contexts, understanding why a login would be flagged as risky is pretty much as important as the prediction itself. Let's see, another key takeaway is the value of combining both supervised and unsupervised learning. Supervised models are really good for known threats, whereas unsupervised models will provide additional coverage for novel or unknown attack patterns. Together, they're going to create a much more complete detection strategy. In the end, the goal of this project is to demonstrate how machine learning can improve both the scalability and effectiveness of identity security monitoring, while also maintaining transparency and practical usability for real-world IAM systems.